Welcome all. Today we are just going to see about the topic name called planning. In planning, we are just going to see about simple planning learning, slim planning agent. Apart from that, we are just going to use what type of problem we are just going to solve using planning. It will be of two different types. One is of blocks world and another one will of MEA, mean end analysis. Now before going to that, we are just going to start with planning. So what is exactly planning? So we already know about it. So whenever we are just going to use of any problem or any thing, so we are just going to use with the concept of planning. So for any project or any model or any prototype that we are just going to use, so before that we are just going to, the ultimate aim is to use for to achieve the goal. So the main task is to achieve the goal from the problem, and we are just going to identify the solution. So how, what are the things? So we need of basic requirements, we need of input. Based on the input we are just going to process, and what are the techniques, what are the methods. From that we are just going to use what type of problem it have been occurred. From that problem we are just going to solve the solution for it. So based on the requirements we are just going to solve the problem. So the task for mainly used for some set of or sequence of action. So it starts from the initial states and it will be ends with the final state. So especially to start with the initial state that given as an input, from to output state that we are just going to reach the particular goal from the problem to the solution. So that is exactly a planning. So the task which can be coming up with the sequence of action that can be achieved with the goal is called planning. So there are two different types of planning environment. One is of classical planning environment and another one is non-classical planning environment. So first of all, classical planning environment, it will be of different types of categories: fully observable, deterministic, finite, static and discrete. So this topics and all which comes under the types of environment. So they will be of having different types of examples. So non-classical planning environment, that is of partially observable, stochastic with different algorithm and agent design. So now we are just going to move to the problem planning or planning problem. So how actually exactly, if the question is given, so we are just going to start, our ultimate plan is to reach the destination from the input state to output state. So initial state will be given, output state will be given. So current state will be of initial state. How we are just going to move from one state to other state by achieving the goal. So that is of exactly a planning problem. So is the question, so how to go to the next state or the goal state from the current states, either from the initial state to goal state or from the goal state to initial state. So example called forward chaining as well as backward chaining, that is of 8 queens problem or n queens problem is a good example for your this one planning problem, or it can be of backward chaining or forward chaining is a good example. So it involves two different types of things. One is how and when. So whenever we are just going to plan, so we are just going to represent the problem correctly or properly. So once the problem have been identified, based on the problem only we are just going to assume the set of operators, set of goals, set of tasks that we are just going to involve. So once if you are just going to planning, we are just going to have these types of constraints to it. So for representing each and every problem, so we are just going to map the states, action as well as the goal. So based on the states will be of, it will be of initial state and it will be of an goal state, it is our final state. So these will be of some parameters that we are just going to set. Action will be of what type of action, so we are just going to move the operators left, right, up or down, what type of action. And finally goal state, once the goal state have been achieved, the problem of for the solution it gets over. So for the representation, So we are just going to use of so this type of an language. So what type of language? One will be of scripts. We are just going to use for this particular type of blocks world problem, and so many problems are there. So that will be often concrete, understandable, and expressive. So these will be often some representation for the problem. In a broader perspective, there are so many methods or things are there. So we are just going to use some logic based on the particular problem. So one is propositional logic, predicate logic. Predicate logic is also known as first order logic, and how we are just going to assume the states for each and every variable. So now we'll see the diagram for it. So the diagram exactly we are just going to represent how we are just going to focus on. Before going to planning, so we are just to have the action, what type of operator, and what are the states that will be available. So based on the planning, these different types of problem will be occurs, and we are just going to achieve the goal. So if it is of sub goals, we are just going to assume at the partial, and we are just going to from that we can extend, and we are just going to reach the goal for it. So these are about the planning problem. And simple planning agent. Simple planning agent is also one type of an planning agent which can be applied with the knowledge and what are the problem that is used to solve to get the solution. It is also performs the following steps. So first, the ultimate goal for setting the simple planning agent is defining the goal. So whenever we are just going to start with the source to destination, so we are just going to set with the defining or identifying the problem based on the goal, that is of pre-planning. So that is of goal is initially set by the agent. So next is planning. So what are the requirements, what type of problem it is. So based on the problem you are just represent with the some existing problem over to it. Based on the existing you are just going to identify and some new technology or new innovation. So based on that we are just going to achieve the planning as which we are just going to inbuilt on it. So and finally the third point is that taking an action. So based on the taking an action we are just going to involve what type of action according to the plan from the initial state to final state. So what are the methods, how we are just going to use this parameter, and how we are just going to propose this method for it. So this is exactly a how we are just going to propose your method based on the action. So that is of what type of operator, what states from the initial to final state, and how we are just going to use the language for it. Based on that we are just going to represent it. So planning that can be involves reasoning. So about the action that can be of carried out with the agents. So the reasoning that can be involved with the planning, so that can be represented with the agent has based on its action. One is of there are two different types of reasoning for this particular planning. One will be of hard constraint and another will be of soft constraint. Hard constraint is that so objectives have to be achieved completely for the success. So soft constraints can be achieved as much of possible, mainly based on the preferences. So that is about the hard and soft constraints. Next is that we are just going to take about the assumptions of agent. So assumptions of agent, there are four different types are there. So especially the action can occur only one at a time. So there are no parallel execution can be done, and they cannot be divided further in terms of the particular problem. So second point, there is no uncertainty and the agent is well versed with the outcome that is specified with proper action to it. And each and every planning according to that particular agent, they will be having some rules and constraint for it. So based on that which is not specified, that cannot be assumed as false. So some cases there will be of the condition will be of true, so in some cases it will be of false. So we cannot assume, we cannot mention as according to that particular rules and regulation, according to the concept that we are just going to face it, and that we are just going to focus on to that particular problem. So the agent action causes the changes in the state and it has the knowledge about it. So this type of an environment is fully observable. So fully observable, it's a good example. So we can take it as a chessboard. So there it is a two-player game. So basically there will be of the ultimate aim for the particular chessboard is a two-player game. So black coins and white coins will be arranged. So it will be of 16, 16, 32 coins will be arranged. So ultimate goal to reach the particular thing is either the player 1 or player 2 want to win or lose the game, or finally it will be of tie. So the actions that can be performed which can be observable, so it can be viewed. So both the persons, what type of coins that can be moved either a forward or backward or reverse or left, up and down, whatever the actions that can be performed with the which is already known to the other person. So that is exactly a thing. So the mainly the set of operators from the initial state to our final state is to plan accordingly, and we are just going to detect the final path of it. So this is about the fully observable. So what are the different types of planning languages that can be used with the planning problem? So initially there will be of planning languages that can be used to describe the environment condition which is used to lead the desired goals by generating the chain of action based on this condition. One is trips, other one is ADL, and other one is PDDL. First is trips. Strips, the expansion for strips is Stanford Research Institution Problem Solver, an action language which is a part of the major planning system for the same name. So the good example for the strips that we have been used for this planning is one is Block's World Problem and another one is MEA, Mean End Analysis, ADL. So ADL is also one of the action description language. It is also used for the strips extension that can be supports the negative literals, quantified variables and goals that we are just going to use in the predicate logic with the symbols called there exists some and for all. So for each and everything that we are just going to use some conditional effects and disjunction in goals, but it is not allowed in the strips. Only for the strips it can be allowed this type of an quantifiers which can be used in the predicate logic. PDDL, Planning Domain Definition Language. So it is also one type of an attempt to standardize the planning language such as strips, ADL, and more other representation languages that can be involved with some logical representation, either a predicate or a proportional logic. Next is that we are just going to use with the strips languages with the help of blocks world problem. So first is we are just going to use the goal stack planning. So here blocks world problem. So blocks world problem is that, so in this particular diagram itself it is initiated. So there are three different types of blocks are there, A, B and C. So which is available and it can be available and it has been placed in the surface on the particular table. So first blocks were a flat surface that can be placed with the blocks of ABC that is placed in the table. An adequate set of identical blocks which is identified by each and every letters like A, B and C. So the blocks can be stacked one on one to form a towers of apparently unlimited height. So this is the initial state, and finally on what state that can be reached will be given for your exam pattern. From that we are just going to move each and every steps and we are just going to achieve for it. So that is an exactly of the particular problem. So that can be moved. It is like a tower of Hanoi problem, which is used in the application of stack. So the stacking is achieved with the robotic arm, which is we can be used with the fundamental operation for picking, moving from left to right or right to left or whatever the position. Some operations can be done, and the states can be represented by using the logic and combined with the logical operations. So especially of proportional or predicate logic that can be either move with proper solution for it. So the robot can be picked only one block at a time, and only one block can be moved at a time, and it can be placed in the surface of table. So this is about the problem constraint. So which will be of specify with the initial state S, goal state G, and set of strips action. So which can be seen in the next slide of it. So the blocks world problem, how we are just going to use the goal stack planning. So in that surface, you will be having of X, Y, which is together available in the one part, and B is separately used of it. So we are just going to use the robotic arm for picking, and we are just going to move each and every block according to the initial state. We are just going to place in the final state of it. So first is pick up of X. So in the precondition, we are just going to initially the arm is empty on table X, and X on table clear X. So X action effect will be of holding X. Why we are just going to pick the arm for it, put down. So holding of X, arm empty on X comma table, it will be of clear of X. So again we are just using of X comma Y, which can be represented with stack holding X clear Y. So now in the surface, what type of action we are just going to use is that on of X comma Y, clear of X, arm will be of empty, and unstack X comma Y. Now at the precondition, we will be having of on X comma Y, clear of X, arm empty, holding of X, and clear of Y. So we'll see the other example for it. So now initially we are just going with the other type of an good example for it. So initially in the start state, A and B in the surface of the table, robotic arm is there. So our ultimate goal is to reach that A and B, which can be picked up one by one, and you are just going to replace in the particular goal state. So how we are just going to use with the strips problem. So strips problem, especially with the start state, we are just having on of A comma table, on of B comma table. So now initially we are just going to set with the on of A comma table. In the right hand side we have been used with it stack of A comma B. So in it A holding A, clear B. So our ultimate goal is to reach the destination A and B. So B is already on the surface. So our ultimate goal is to reach A. We are just going to pick with the robotic arm and placed over at the top of the B. So that is of using with that. So while using, so we are holding up A and pick up of A. Once after the B is already placed in the surface of the table, you are just going to keep the A at the top of the table. So that is about that. Once if it is done, arm is empty on A comma table and clear A. So finally at the initial state of the A and B will be on the surface. We are moving the particular goal is to reach is that above B we are just going to place A. So that is already achieved, and now the representation of the state, it can be represented of on of A comma B. So how we are just going to start, and how we are just going to start with the initial state and end with the goal state for it. So this is exactly how we are just going to define in it. So this is about the goal stack planning. So other one example for strips planning, which comes under the planning problem. So with this three states, initially you will be having A, B, C blocks which is available in the surface of the table. So now your ultimate task is to reach the final destination or goal state is that A, B, C want to be in a single block. So initially while representing the strips planning, so how we are just going to have the particular representation of the language that can be represented as on of A comma table, on of B comma table, on of C comma table. So now we are just going to have the clear with each and everything. Clear A, clear B, clear C. So now at the initial state at the S naught, we are just going to move the other component that especially your ultimate task is to A want to be top, B in middle, and C in the bottom, in the top, in the surface of the table. So now we are just going to move the B onto the table of C. So now how it can be represented? the second block you see it on a comma table, on b of b comma c, on of c comma table. So now we are already clearing with a and b clear table. So now the ultimate goal is to move the representation. So it is fixed with a is separated and C above B is placed. So that is about the next concept. Now the ultimate goal is to reach the A wants to be available at the top of the B. So that is your ultimate goal. For that we are just going to use on of A comma B, on of B comma C. So on of C comma table, clear of A. So clear of table, and finally with your representation with the move of a comma table of table comma b. So your ultimate goal is to reach the final destination is on of a comma b, on of b comma c. So that is your final goal state, how we are just going to make use of strips planning from the initial state to final state with the help of planning problem. So this is about the strips planning. So next concept, we are just you have the concept called in a planning problem we'll be having of MEA. So that is of means end analysis. So means end analysis, it is also one type of an combination of backward and forward search technique. So it is often one type of a mixed strategy. For initially we are just going to identify the problem first and small and solve the little or smaller problems, and we are just going to combine each other and to form the particular problem will be have the uh, analysis or not. So that is about exactly a mean end analysis. So it is also a process that can be centers around for finding the difference between the current state and the goal state for it. So how we are just going to work with the mean end analysis for solving a problem for this particular solution. So first of all, in the first step, we are just going to evaluate the difference between the initial state, or we are just mention of the current state to final state. It is often goal state. Second point is that select the various operator which can be applied for each and every difference for it. And third one, apply the what type of operator that you are just going to apply with the difference. And it is also used to reduce the difference between the initial state and the goal state for it. So example of mean end analysis. So how we are just use of mean end analysis from the initial state to goal state. So initially it has been mentioned with the diagrammatic representation. So with the circle you will be having of diamond symbol, and at the top you will be having of some dot symbol. So it is an initial state, and finally you will be of going with the goal state. So you want to represent only with the circle and diamond symbol at the top by removing the dot symbol. So how it is a problem for solution, how we are just based on the problem we are just going to how we are just going to solve this particular type of solution. So first of all we are just going to identify the differences between the initial state and the goal state for each and every difference, and generate the new state, and it is also used to apply the operators. So mainly we are just using the different types of operators like move, delete and expand. So these the three different types of parameters, with the parameters only we are just going to identify the mean end analysis. So based on the mean end analysis we are just going to start with the initial state that is used to represent the circle. In the inside the circle you will be having of some diamond operation, at the top you will be having of dot operation. So second we are just going to use of delete operation. So the ultimate goal is that we are just going to have only the circle at the bottom, and top we will be having only the diamond. So we will be of removing a dot symbols. For that we are just going to apply with the delete operator to it. So based on the delete operator we are just going to neglecting the dot operator by using the operation called delete from the initial state, and here we are just going to have only the circle, inside that we'll be having of diamond symbol. And step 3 we are using of move operator. So move operator, in sense we are just using of initial state we are just used of removing the deleting or removing the particular dot operator, and second step will be of delete operator, and moving the particular operator and moving the particular operator of the diamond. So it is all automatically move with the circle followed by the diamond symbol at the top. So after that we are just going to extend the particular diamond operator, which is similar to the circle operator. So first initially the fourth step, apply the extend operator. Initial state will be of like inside the circle you will be having of diamond operator, with the top you will be having of dot symbol, and we are just use deleting the dot operator and moving the particular diamond operator at the top, and finally we are just going to expand the particular diamond operator to reach the initial state to goal state by using of mean end analysis. So this is how we are just going to represent the particular problem planning for blocks world problem as well as mean end analysis by using of planning problem, or we are using of some languages for it. So now, so this is the algorithm that we are just going to use for the particular mean end analysis. So step 1, it is used to compare the current state to goal state. So you are just going to check the differences between both, whether it will be of success, then it will be of return to it. And step 2, so else we are just going to select the most significant difference, and it is also used to reduce the following steps until whether the particular goal have to be succeed or failure occurs. So first, select a new operator O which is applicable for the current difference, and if it is of no such operator is used, then the signal will be of failure. Second will be of attempt to apply operator O to the current operator. Make a descriptions of the two states. So first is we are starting with the O, and each can be represented with the precondition. Whether the precondition has been satisfied, we will be moved to the next state for it. So once the result have been identified, the state will be, the result will be of O where applied in the O state. C will be of if. The first part will be of mean end analysis of current comma state, current of start, which can be represented by using the three different types of operations like delete, move, and expand. And the last part that we are just going to use with it, one will be of an MEA of result comma goal. So once if it is of successfully completed, we are just going to stop the signal for the particular success, and returns the result of combining first part O and the last part by moving the operators of move, sorry, delete, move, and expand. So this is about the mean end analysis we are using in the simple planning problem. Thank you.